That's disturbing.
Just my best friend.
Okay, look up, please. No one top. Okay, quiet. No one stop. There we go. Okay. Okay, I passed this out to A1, and then we just didn't use it enough to worry about really having it as a note. I think if you just watch here, you'll be fine. So what I've drawn here is a really, really simplified version of two functions. The idea being that I purposely made the functions go through very distinct points so that as you look at the screen, you don't have to use a lot of mental energy to compute values. You can just look at it. I want to emphasize a simple concept, but like a lot of things in this class, it's crucial. It's no different than the traditional, I've done this before, raise your hand and tell me what is 6 times 8? That was not me raising your hands, but whatever. Hands back down. Raise your hand, please, if you can tell me what is 8 times 7. Okay. What is 8 times 7? 8 times 7. Chris!
56.
Somebody do it. Boy, it's good for 3. Take 4. Okay. Okay. Look. Okay, just like that. Look at me. Come on, look. Don't talk. Continue spreading is fine. Look at me. Look at me. Look at me. Don't talk. Okay, so just like you can, that quickly say that 7 times 8 is 56, on the pink packet, as well as some future AP problems, you're going to have to be able to look at a graph, typically 2 graphs, and that quickly identify the following. If I call this function here f, and I call this red function g, we are going to need today to be able to make computations like this. We have to be able to look at this picture and say, if I draw a line from here to here, I need to figure out the length of the line. Well, it turns out to be really simple. This y-coordinate at the top is 5. This y-coordinate at the bottom is 2. Therefore, the length of that line is 3. Cool? Okay. If I draw the vertical line somewhere else, like say here, what's important to notice is I don't have to change logic. This y-coordinate is still 5. This y-coordinate is -3. But the length of the line is still computed by subtraction. So I simply took the y-coordinate at the top and I subtracted the y-coordinate at the bottom. It didn't matter that in this example in blue, both y-coordinates are positive. In the purple example, one y-coordinate is positive, the other is negative. I still use the same exact logic. Y-coordinate at the top, subtract y at the bottom. If I come over to this space, and I need to find how long, say, this line is, I can still use the exact same logic. The y-coordinate at the top is 0. The y-coordinate at the bottom is -4. So simply by subtracting, I can calculate the length of that line. Questions? Okay, it's really that simple, just make sure you don't forget. Working a problem, you have some need to find the length of a vertical line, it's always y at the top, subtract y at the bottom. Okay? The pink is not homework. I don't really want you to worry about doing homework over the break. So what we'll do is today in class we'll get as far as we can. And then when you come back from the break, the Monday back, we'll finish working on this. But you don't need to work on it at all outside of the room. We'll just work together. So, you have two. You need to. As soon as they're picking up that phrase. I don't want to take it away from you. It's like I expect that on purpose. Okay, so go to the pink, please. Go to the pink packets.
That is colorful.
So number 1 on the pink packet. Go on top. Okay. This is not new advice. Just re-emphasizing. It's crucial in the test that you've got to get rid of your ACT habits. They are not helpful on the AP Calculus test. Okay, most people's ACT habit is to like rush like crazy, like just go as fast as you can, because that's helpful on the ACT. It is not helpful on the AP Calculus test. You want to read slow and careful. Otherwise, your brain will say, "Oh, this is just like this other problem," and it won't be, because the writers constantly find ways to make the problems different. Okay, it says let R and S be the regions in the first quadrant. I stop right there and I go, okay, first quadrant. So that means one of the boundaries they are describing is this. First quadrant. The region R is bounded by the x-axis. So here's R. A boundary of the region R would be the x-axis. And the graphs of y equal 2 minus x cubed. So that's this. And y equal tangent x. Like so. The region S is bounded by the y-axis. So that's over here. And the graphs of 2 minus x cubed. Okay, good. So I figured it all out. Questions? Just reading so I make sure I know what they're talking about. Question says, part A, find the area of R. So I'm supposed to find this area. Okay, finding area on the AP Calculus test turns out to be really, really simple, as long as you just follow a very logical sequence of thoughts. And the good news is this is a very you just follow the logic, they really can't trick you. You'll be fine on pretty much any area problem they give. So I want to find the area of R. I'm going to make this picture a little bigger. It makes drawing a little bit easier. So we'll lose some of the words, but we don't really need them anymore. So hold on a second. So let's make this a little bit bigger, just to make the drawing a bit easier. Okay. I'm trying to find the area of R. Okay, here's where you always start. You remember that for calculus, the way we find area is we find the area of one rectangle, and then we simply use that knowledge to find the area of many rectangles. The rectangular area we find is going to be very, very narrow. So I'm going to draw rectangles. I need to find the area of R. I do it one thin rectangle at a time. So for example, I might find the area of that narrow rectangle. So the line is representing a rectangle, not a line. It's just very narrow. Are you with me? I'm going to repeat that process over and over again. I'm going to find an area of this rectangle. I'm going to find an area of this rectangle. This one. And just keep going. I am not showing every rectangle, just representative samples. The white space in between, all of that white space needs to be filled with rectangles. I need to find the area of each rectangle. Okay? Okay? So here's where the last discussion becomes important. To find the area of this purple rectangle, I need to know how long the rectangle is. Well, like we just discussed, easy. If I know the y-coordinate at the top and I subtract from that the y-coordinate at the bottom, I'll know the length of that purple rectangle. So that purple rectangle's length is going to be, let's see, it's this y-coordinate, which is found using this function, subtract this y-coordinate, which is 0. To make the problem a little easier to discuss and to also prevent mistakes, write on your paper, very top here, f of x equals 2 subtract x cubed. And then write below that g of x equals tangent of x. Okay, that just makes the discussion go a lot faster. It also prevents mistakes. Okay, so this purple rectangle, the y-coordinate is found using g. So I'm going to take the length of the purple rectangle, that's going to be the g formula, subtract 0. Okay, I want everyone to answer this. Feel free to talk to each other. If I were trying to find this exact length, this formula will do it for me, but I need one more piece of information in order to make this formula accurately find this length. What other information must I plug into this formula to make the formula accurately compute the length of that purple line, the length of that purple rectangle? Talk to each other, then raise your hand. What do I need? Hands up, who knows? About half the room, maybe, third. What am I missing? What information do I need to truly find the length of that purple rectangle? Sydney? I need an x-coordinate. I need to know what is this x-coordinate. So I'm cheating a little bit because I've done the problem before. This x is going to be about 0.4. You'll see why in a minute. So if I plug in x equal 0.4 right here, g of 0.4 will be this y-coordinate. Y at the top, subtract the y at the bottom will give me the length of the purple rectangle. How many were prepared to answer as Sydney? 2 points, 3 for Sydney. You need me to talk more about it. So the formula for the green rectangle is just the same thing. G of x, subtract 0, except that I would be using a different x-coordinate. Say maybe about 0.6 or something. Otherwise, the formula is the same. You need extra explanation on that. Keep going. The blue rectangle, length is going to equal g of x, subtract 0, except that the x-coordinate here is somewhere about 0.9. Putting up the orange rectangle, that's going to be about x equal about 1.1. I have the pink rectangle. And that x-coordinate's about 1.2. Question. I deliberately made an error in my logic, hoping that you would notice, but without me telling you, sometimes you feel like maybe you're mixed up. But no, there's something wrong with what's written on the board. Talk to each other, raise your hands. More. The x-coordinates are fine. These x-coordinates are logical. There's something wrong here. I'm trying to find the length of each of those narrow rectangles. What I've written is not totally correct. Partially correct, but it's not totally correct. Talk to each other. Show me your hands. Who sees it? Who sees my deliberate error? Who sees the deliberate error that I made, Dawson?
When you switch to the other line, you should use f of x instead of g of x.
So the orange rectangle, the top y-coordinate cannot be found using g, because this top y-coordinate is touching the f function. So the orange has to be f of x. And the pink as well. So this should be f, and the pink should also be f. I've had their hand raised and do it. 2 points, 3 for Dawson. Please, Mary.
I think also you skipped one of the lines. You skipped the right.
Oh, you're right. I'll give you 2 for noticing that. 2 points. Anybody else? Please.
So the blue, what would it?
The blue I tried to hit right at the middle, so it would work either way. Yeah, because the y-coordinate here can be found using either function because it's an intersection. 2 points. Anybody else? Please. Oh, I will explain that in a moment. Good question. As long as it makes sense to you that if you knew the x, you'd be good, then we're fine. Anybody else? Okay. So on the board, I've got a way to find 1, 2, 3, 4, 5 rectangles, as long as, like Justin said, I know the x-coordinates. I need a way to find an infinite number of rectangles. Okay? I want to find each and every rectangle. So that's where we're going to use integration on this problem as well. What we'll do is, let's copy this. Is instead of calculating the length, I can actually calculate the area of each rectangle. Easy question. I just want you thinking with me. Hands up. What else do I need to calculate the area of each rectangle? Don't overthink it. Just want you to think with me. These were the formulas for finding the length of each rectangle. What else do I need to find the area of each rectangle? It's not complicated. Just hands up. Sophie?
The width.
You knew it? Point 2 for Sophie. So the area of the purple okay, look. So we're going to find the area of the purple by doing, back to Justin's comment, we plug in x equal 0.4 into g. That calculates this y-coordinate. We take that y-coordinate, subtract 0. We get the length of the rectangle. Notice I changed this to a. We then multiply that length by some very narrow width. dx means a very, very tiny difference in x. So it's like a very small amount of x. That's our width. We do the exact same thing for the green. So we make the width of each rectangle the same. The heights of each rectangle are different, but the widths are the same. So. Question? Awesome. So all we have to do is set up an integral now. The integral is going to look like this. We're trying to find the area. I guess I should say the area of R. So area R is going to equal, what we want to do is we want to start with an x-coordinate of, right here is x-coordinate of 0. We want to go to this x-coordinate. So I need to find that. So So I grab my calculator. And I type into always, okay, to avoid mistakes on a test, always put F in Y1, always put G in Y2. So, on my paper, that's what I've written down. F is going to go here in Y1, G is going to go here in Y2. So do that on your calculator. Okay, we used the calculator a little bit earlier in the year, but a couple reminders. One, you have to make sure for this class your mode is in radians. For this class, you must have every answer to 3 decimals or more. So to make it a little easier for us to discuss, we'll just always do 3 decimals. So you need to make sure this is set to 3. You need me to help anything so far? Okay. One of the most important things about using your calculator on the AP Calculus test is you've got to make sure that you get the right window. In many problems, the information given will tell you the window. When they don't tell you the window, I have found that the very best first guess is 0 to 5. So I go window, 0 to 5, zoom fit. And we'll wait till everybody gets this on their screen. So I'll pay you extra credit. Raise your hand if you have that on your screen. Show me your hands who has that on their screen. Show me your hands who has that on their screen. And 2 points. Good. You don't even need me to come look at their calculator to make sure they're getting that. Cool. Let me show you. Okay, I believe I showed this. I'll come in a second. Sorry. I believe I showed you this earlier in the year. If you are taking the AP Calculus test and suddenly your calculator is not behaving as expected, one of the most common errors is on this screen, you have accidentally turned on plot 1 by somehow highlighting plot 1 like that. So one of the most common errors is that happens. Easy to fix, you just turn plot 1 off like that. Okay. Another common error is when you're typing the formula, instead of typing subtract, you'll type the negative. It's smaller. That's also common. If it's not one of those 2 errors, you should just reset your calculator and start over. So to reset, and this is what I would do on yours, you go second. The memory key is right here is the plus. Then you choose 7. Then you choose all RAM. And if I say reset, it will erase what I've done and start over. I can do it because mine's stored. So I go enter. And now it starts fresh. It will change. My mode will be radian, which is what I want. My decimals have change, so I'm going to change those back to 3. Everything else is fine. So I can reload the file here. Hold on. Anybody else need me to look at theirs? Or did you guys anybody else need me to look? The word here. Okay, next thing. Okay, the next step is a bit of a guess. But it doesn't take very long, so a guess in this case is okay. Usually I keep telling you don't guess in this class, it's not helpful. This is one case where it's fine. Just look at the picture, look at your calculator screen, and make a guess. Guess whether or not you go back to window, and you either want to change this to 10, or cut it in half, like say 2. I wouldn't do decimals, just 2 is fine. And just guess which one seems better. What do you think? 10 or 2? 10 or 2? 2 sounds like what most people are saying. So 2, zoom fit again. Your zoom fit works a lot faster than mine, so mine's a little slow. If you change the window, you have to hit zoom fit every single time. Otherwise, it doesn't help. So. Okay, still not seeing what's on the paper, so I have to make a choice again. Should I have gone to 10, or do I need to go to 1? What's your vote?
1.
1? Now it's looking pretty good. So. Question? Pretty darn close to exactly what I need. This, I need to kind of see this part here. So this is x equal 1. So that looks like about 1.2 or 3 maybe. So we'll go 1.3. Questions? Oh, please, Mary.
Oh, so I was just wondering, like, why do we need to get like so precise?
Oh, outstanding. 2 points. So one reason I want to make sure I see this pretty good is to make sure I have not typed something wrong on my calculator. So it is, I think it really will prevent errors to just, it doesn't have to be precise, but good enough that I can feel comfortable that I've not mistyped something. Other than that, the only thing I've got to do is I'm trying to find this area. So I've got to know this x coordinate. We've already talked about how that's important. And I'm going to need this x coordinate as well. Otherwise, it doesn't matter. Yeah, 2 points.
My calculator isn't giving me that.
I'll come look. You're good.
You're so thin. Nano, do you see trout reams often? How about you, Luke?
Salmon.
Anybody else need me to look? Okay, so I need to find those x coordinates. So I use the intersection. So I go second, trace, intersect. The calculator is asking, would you like to use this curve, I'll be there, this curve to find the intersection? I do. So my answer is yes. That means I press enter. If my answer was no, I would use the up-down arrow to find the curve I want. But I only have 2 of them, so that's fine. Second curve, yep, that's the one I want. Guess means put the cursor near the intersection. It doesn't have to be really very close, just that's good enough. Okay, key thing. Warning to everybody. Huge warning. Do not proceed past this point unless your screen says intersection. If it doesn't say intersection, something's gone wrong, and you will get a wrong answer, and you'll lose not 1 point on the next test, you lose 9 points on the next test. Okay? So it happens really quickly. So a key to this next test is like just learning habits that prevent mistakes. So make sure it says intersection.
Okay, mine about this, right?
Next thing, one rule of the AP test is we need to use this value, x equal 0.902. You cannot use it as written. The actual value is something like x equal 0.90275643897. Okay? You've got to use all of that. So what you want to do is store the value in your calculator. You have to store it. So to store this, you're going to hit second quit. Gets you back to the main screen. On the main screen, you remember, I need to store the x coordinate. So you type x, and then you press store, right here above on. And you tell the calculator where you would like to store that value. A works great, so I say alpha A. And again, don't just do the work, think as you go. So look here and say, yep, that's the value I remember from the other screen, so I have stored the correct value. Please.
I still can get the intersection.
Let me look. Good.
Okay,
Oh, you have to use second quit. What you're doing is you're accessing this calculation.
wait, how do I run?
Call me back.
Wait a second, you do alpha.
You're just saying have a lot of
Ton and pan thing.
Anybody need me to look at their calculator?
Or A's. Except for wait.
help.
The letter.
Close, but we're close to God.
Like 9 times software. You could do online Saturday. Or where is he going again? I know, yeah. He goes to my transmission. Are you our work? Stay. We're gonna stay? Yeah. You want to go? I've been like twice.
Help! Help!
No, my parents do it at the same time. Yeah. We would have to know. I'm the only one that's
That is
I've been like 3
Wait, what? What did you do? You just did that.
What I'm saying is I hear.
Oh, okay. I was like, oh, so because I thought you just. Oh, okay. Wait, did you go to the graph? Yeah, maybe I can. Okay, when I'm doing it, like, look, it's in the intersection of now. What am I doing wrong? Luke, I need I don't need Dawson to see this. I need me to see. I know how I see this.
I like to make it more
Smack my belly and call me First things first on the wheels.
Anybody else can you look at their calculator? Okay. Look up. You also have to find this x coordinates. Use the 0 function to do that. Say second, calculate 0. It's asking for the left bound. So I have to identify, put the cursor left of where the 0 is located, put the cursor right of where the 0 is located. Come on. Make sure the screen says 0. So one more time. You're on the graph. You say second trace. You choose 0. You have to position the cursor to the left of where the 0 is located. Now you have to position the cursor to the right of where the 0 is located. It says guess, so you just put it near the 0. And make sure your screen says 0.
Wait, what's your window on this?
So once I get the window set, I don't change it. So I'm still at that 0 to 1.3 zoom fence. Oh, I'll show you. Points for credit.
Do you want to see how much acne you have?
Actually, this is.
How about you, Luke? Offer hold, yeah.
Hey. We need to come look at their calculator. Awesome. Okay, this has to be stored as well. So I'm going to put it in B. So I second quit. X again, store B. The other thing that, Lizzie, there's something else too, like when you move the cursor around to select things, it changes the icon of the selector. That also has something to do with like getting that to work properly. But I can't remember. Yeah. Okay, you would need me to come look at their calculator. Awesome. Oh, sorry, you're good.
I wear this all the time. Stop.
So you just, if it's on one Zoom event, it's just on Zoom, right? You don't really need that.
Okay. Silence. Everybody look up. Everyone look up. Okay, back on the paper. Again, this question on the AP test is worth 3 points. So on the Unit 4 test, you'll take it at the end of January, it's going to be worth 9 points. Okay? Because my scale is a lot. This is different than the AP scale. Okay, 2 of the 3 points or 6 of the 9 points will come from what you write, not what the answer is. So you must develop the habit of writing precisely what you need to get the points. Okay, remember, it's really simple logic. I am finding the area one rectangle at a time. So over here, the way I find the rectangular area is by using this formula. So I write that formula inside the integral, parenthesis. Do not forget the leading parenthesis. This test is graded very strictly, just like the AP test. If you forget the parenthesis, you lose the point. Like, there's no mercy. There's no, oh my gosh, that's stupid. Oh well, sorry, that's how they grade it. So we can't control that, so I have to get you in the habit of being precise. So parenthesis there. Okay. It's crucial that you be able to look at that and identify what it is. So I want you to say it. If you can't, no worries, we'll practice again. But what is that? What is that? G of x minus 0. What is that? What is the purpose of that? Why did we write that? Lauren?
That's the length.
Perfect. It's the length of one rectangle. This is the formula for finding the length of one rectangle. How many knew it? 2 points, 3 for Lauren. Okay, Lauren, sorry. What's the purpose of the x in the formula? Hands up, come on. Why does the formula contain an x? This is how we find the length of a rectangle. What is the purpose of the x?
It's one of the x coordinates on the graph.
There are rectangles at each and every x coordinate. This is so we can specify which rectangle's length are we trying to find. How many knew it? 0.2%. What's the purpose of dx? Hands, come on. What's the purpose of the dx? Sarah? Find the width of each rectangle. You knew it? 0.2%. Good. So what I want to do, hey, I don't want to find the area of one rectangle. I want to find the area of each of them. So I'm going to start with an x of 0. And I'm going to use every single x coordinate until I get to this x coordinate, which was 0.902. Is that correct? Okay. Do not make this error. You cannot write 0.902 here. You have to tell the grader. This letter A here, it's not going to show up on your work because you're just going to jump to here. You're going to tell the grader that A equals 0.902. And then right here, because that's where you put A in your calculator, you're going to write A. Do not forget to tell the grader that A is equal to 0.902. You lose the point. Questions? Please.
Why can't you just put 0.902 on the top there?
So legally, you can put 0.902 here, but when you run the computation on your calculator, you have to use the stored value, which is an A. So in an effort to try and get you to not make simple errors, like forgetting to use the calculator, I'm trying to get you to develop the habit of, no, I always have to use the stored value, so I want to write down where I stored it so I don't mess up. And then as long as I tell the grader that this is 0.902, everything's good. 2 for Luke. Please.
Are we allowed to use the calculator on the test?
So Unit 4 is a calculator allowed test. Half of the AP test is calculator allowed. So this homework, you'll notice like it says everywhere calculator allowed, I believe. So like over somewhere it's right there, calculator. Anybody else? Please.
So with this, are we using the fundamentals of practice, or are we just using like integration and like our own?
Awesome. Hey, listen. Take 4. Look, she asked a really good question. She said, are we using the fundamental theory? We are not. We're using integration because we remembered that integration is not something complicated. Integrating just means to multiply repeatedly and then sum them together. That's what we need to do. We need to do this multiplication, right? And then we need to do it again and again and again, and then we need to sum them up. So we are using an integral, but we're not using the fundamental thing. Perfect. It's actually simpler in my opinion. It's like, oh, rectangles, easy. Length times width, do it again, do it again, do it again. I need to do this. That's going to get this area here. Like it will find the area of all of those rectangles, add them together to get that area. Area R has to include this as well, so I do plus. Now I go from A to B. I need to tell the grader what B is. That's right here. So that was 1.260. Please, Jesse.
How does that, the 1 G max minus 0 count for all of this?
So
Each of those is for 1, right?
So remember, this is the formula of the purple rectangle as long as you plug into that formula the appropriate x-coordinate. The formula for the green rectangle is the same. It just requires a different x-coordinate. So the integral takes care of that. Because what the integral does is it takes this x-coordinate, plugs it in, then it goes to the next x-coordinate. It just goes in sequence, x after x after x.
I asked you
Please.
when writing the integral, is it like if we put a on top instead of b, is that wrong?
2 points. Yeah, every 1 second, Brian. Carson, it is, I will show you in the future that it is actually possible to have it backwards, but it causes errors. So I don't really want to encourage you to do that. No, we got to go from A to B. Mary?
On B, like 1.260, do we have to do the 0 on the AT test?
Because the AP always requires 3 decimals or more, I want you to have the habit that every time you write a decimal, you always write 3, unless you know for certain there are no others. Like if you know the value is exactly 1.2, then you can just write 1.2. Otherwise, to prevent mistakes, you want the habit of always doing 3. Does that answer it? 2 points. 3 points, sorry. I went 2 points. Since you asked about decimals, please.
I like get that we stored the A and the B in the calculator, but I'm just like confused like what those numbers like mean.
So again, this is simply the x-coordinate of this point. Because were you okay that this finds the area of that rectangle as long as we plug in the right x? And then again and again and again. So we're telling the integral to use every x from 0 to 0.902. So you have to specify to the integral at what x you want to begin. You want to do every single one in between and then stop. 2 points, please.
Does it matter which line is f of x or g of x?
It does not. Only that you keep track of it. Yeah. 2 points. We good here? Oh, please.
Are we like are we allowed to use g of x and f of x without specifying which one is which? Or we need to specify that for the grade, for whoever's grading as well, because otherwise we just need to put like a tangent of x at 2 minus x cubed, right?
Yeah, listen to Abby, please, everybody. Listen. Take 4 for that one. Listen. If you develop the right habits, you won't lose silly points. You just got to get the right habits, make sure you use them on your homework. So again, this is another example where you're not supposed to do the homework, you're supposed to think as you're doing the homework. Like think about, hey, if this were a test question, what would I have to write? And then make sure you're writing what's required. Because the problems are going to get, some problems in the future will be a little bit messy, meaning the formulas are kind of big. I don't think it's smart to keep writing the formulas. That tends to cause mistakes. So what I will always tell you to do is tell the grader, F is this formula, G is this formula, and then just use F and G. But Abby's right. If you don't tell the grader, you have suddenly lost 2 of the 3 points. Because he can't tell, or she can't tell, so. Yeah. Awesome. So this one becomes F subtract 0. Now, hey, I'm writing subtract 0 because I'm trying to emphasize that you, in finding the length of the rectangle, you're always taking the y at the top, subtract the y at the bottom. You don't have to write subtract 0. That's just me emphasizing that for you. So, good. Okay, at this moment on the AP test, you've earned 2 of the 3 possible points. All we have to do now is make sure our calculator produces the right decimal result. So back to the calculator. Math 9. Whoa. Usually causes smiles around the room. 0 to A. I need g of x. G of x is stored in y2. So you do alpha, trace, and you see the list. So you choose 2. And dx, then plus. If you need me to come look at it, just wave me over. So. Oh, yeah. Talk to me after class.
I can bring a different calculator.
Oh, bring a different calculator. Yeah, it's just, I can show you how to make it work. If you have another calculator, it's not worth it. It's just, it's too hard. If you have another calculator. So.
Let's say the 0 is like a 2 or something. When we're writing this on calculator, we can want to do
Yeah.
But because it's 0, we have to.
Perfect. Hey, look up. 2 more for Elena. Listen, Elena said, you said that perfectly. I just have to show everybody. Look. Okay, I have written on my paper y2 subtract 0. But I obviously don't have to type subtract 0. However, you will encounter problems in the future where your formula on the paper is going to be like Elena said, y2 subtract 6. You have to write 6. Cool. So get rid of that. Then just next integral, so math 9 again. A to B. Y1, so alpha trace. Dx, enter. Anybody need to come look at their calculator? Does he figure it out?
Almost.
This one I can show you. That store thing every year I can never remember why it was.
Luke, what's your favorite kind of soup?
It's like
Red and white can.
Spaghetti?
No, it's like a Campbell's.
Campbell's.
I want to sip this whole glass where I
That's
so then
I've always been myself in a cannon and shoot myself into the ocean. Like you know, like skip machines, where you can like skip run perfectly. Skip across.
Okay, next thing. Can you go to number 2, please? Go to number 2. Go to number 2. Okay, the logic doesn't change. You just have to go through a few AP prompts so you look for things that they might do that are subtly different, that might throw you off. They ask you to find the area of S. So I again think of narrow rectangles. So I need to find this rectangular area. Then I find several more. Remember, the white space is filled with rectangles. And what I'm paying attention to is the y coordinate at the top of each vertical rectangle and the y coordinate at the bottom of each vertical rectangle. And in my opinion, I discover something that makes this problem a bit easier. The top y coordinate of every rectangle is always touching this function, which I called f. And the bottom of every y coordinate is touching the function which I labeled as g. So finding s is a bit more straightforward. I integrate from x equals 0 to x equal a. The y coordinate at the top of every rectangle is f. The y coordinate at the bottom is g. That's it. Type it in your calculator, press enter. Right, in this case, I can write one formula that will find the length of every single rectangle. Before I had to have 2 formulas for the lengths of every rectangle. Get to work, Lizzie. All right. Let me know if you need help.
The decompose. Yeah, you need to try to spend X.
Yo, Luke.
Yeah.
Raise your hand, please. You got it to work. Show me your hand.
I get these equations.
Hands up. Come on. Who got it to work? Who got it to work? Show me your hand. 2 points. Any questions? You need to look at it. You're good.
Okay, Luke, keep going. I mean, learn these equations. Yo, I know locations. I be up in the sky on altercations. Yo, I'm repping jet engines 300 miles an hour. Yo, let me tell you my situation like a dire. My rhymes are on fire. Yo, let me tell you. I don't know. I don't have much iron. I be repping these steel beams, 300 tons. Yo, let me tell you, I eat so much for so many livings. Those that grill tastier than yo, let me I'm in the wind. I'm telling you about ships. Let me tell you how I'm walking out these links. I think I know you about me shaving it every day. Yo, little thoughts, you know Santa Fe.
Hey, look up. You all need to hear this. Look up. No, 3 points for Tori for asking. Look at me. 3 for Tori. Look. So one habit you want to make sure you are using in the homework, like problem after problem after problem, so you just get in the habit, is make sure you label on the page, you know, what you are calling F and what you are calling G. Make sure you write that down. Second thing, make sure F gets put in Y1 and G gets put in Y2. On a complex problem, if you mix that up, your answer will be wrong, your written answers will be right, so you'll get most of the points, but you'll lose that easy one, which is just getting it in the calculator correctly. So watch out for that. Warning. In the calculator, the symbol is always, you know, Y2, Y1. You cannot use those symbols on your paper. It's considered to be illegal. So on the paper, you can't use Y2, Y1. You have to use F and G. Got it? Please.
Is it possible to choose that in the calculator?
Not that I know of. I think that would be nice. I agree with that. Look. Hey, last thing. Look up. No one talk. No one talk. We've got 2 minutes. Listen. Okay. This is the written section of the test. The next test you're taking in class is also written. So in the back, I've provided answers, but you'll notice the format is different. I'm showing you what is required to get all of the written points. So on problem 1, when the test is graded, the grader is going to look at your work and say, are the limits correct? And as long as you have this notation and it says 0 to A, now they used, they went and found the intersection without a calculator, which is legal but not necessary. So what I taught you as far as going A to B is just fine, as long as you tell the grader what is B. Like you have to say A equals this, B equals this. Then you get the point for the limit. Question? Okay, the integrand point, the grader's looking to see if what's inside the integral is correct. They wrote out the formulas. I don't think that's the best way to do it. When the formulas get complex, that causes problems. So tell them what F is, tell them what G is, write it how I taught you, okay? And then the final point is this correct to 3 decimals? If it's off by 1 decimal, you lose the point. They are not lenient at all. Okay, so just set up your calculator and then just 3 decimals. Remember, you don't need to do any of this during the break. We'll just start again on Monday after the break. Have a really nice Christmas. I'm working a problem. I do. For 5 minutes. Yeah, and once you put the A in the 5
Probably gonna take you.
That's actually how all computer memory works. Yeah, it just writes over the top. So they're two different things. You're just mixing them. So what we did is we said, find this x coordinate.